Hey, happy good morning, pre-algebra. As we chug along through the week, it is Tuesday. I'm excited. Doesn't sound like it, but I am. All right, here we go. Joke for today. Please turn to page 486. There it goes. In your math textbook. A little out of it. All right, here's the joke. What did the policeman say to his tummy? You're under a vest. That's right, you're under a vest. There we go. All right, as we continue on, we're straying away from exponents for a little bit. We'll see them involved in a few of our problems, but it's not the big idea, the main focus today. We're really going to be focusing on factorizing numbers. Okay, so what it's really going to go down to is this thing called prime factorization. So here's just a reminder. A prime number is a whole number that has just two factors, itself and 1. So for example, the number 5 is prime because you can only multiply 1 and 5 to get 5. You can't do any other multiplication of a whole number. Now you could do 2 times 2.5, but we're only talking about whole numbers. So we're not talking about fractions or decimals. And then we have composite numbers. Composite numbers are the rest. Whole numbers that have 2 or more factors. So I'm gonna give you a line of numbers here, and we're gonna determine what they are. So we already know that 5 is prime. Now what can we multiply, what numbers can we multiply to get 6? So again, what are the factors of 6? Well, we can do 1 times 6, but we can also do 2 times 3. All right? That would be the factors of 6. Now let's look at 8. What are some different numbers that we can do to multiply to get 8? Obviously 1 times 8, but we also have 2 times 4. So both 6 and 8 would be composite. They're composite numbers. So first step, looking at the bottom of your page, you're identifying if a number is simply prime or composite. That's all you're doing. Okay? So first couple problems will be just like that. Identify if it has just 2 factors, itself and 1, then that makes it prime. If it has more than 2 factors, that makes it composite. All right? Now look at the other page, 487, looking at the top. This is where we get our definition of prime factorization, and we're going to be creating something called a factor tree. We're breaking down a number, a composite number, into prime numbers. So here is the example. We have the number 20. When we break it down, we're trying to break it down to just easy numbers, so you can choose whatever you'd like. So I chose 4 and 5. Now 4 is still not a prime number, so we have to break it down even further. So when you break it down, 2 times 2, those are the prime factors. So now we're left with all prime numbers. They're all prime. See how I carried the 5 down. So when we're trying to find the prime factorization, you use the factoring tree. All right? So you're trying to figure out what do you multiply, what prime numbers do you multiply to get the number, and it's most likely always composite. That's what you're breaking it down. So if you're going to do 2 times 2, that equals 4, then multiply that by 5 and you get 20. Let's look at a bigger example. What about a number like 90? What are we going to break that down to? So let's choose 2 numbers. I'm going to go with easy ones like 9 and 10. All right, now both of these can get broken down again. So I'm going to do 9, we have 3 and 3, and we can't go any further there, but we still have, I'm going to do 2 and 5. All right, I think, yep, they're all prime. So now our prime factorization would be 3 times 3 times 2 times 5. Now typically they like to put it in a ascending order. So that means that we would really move the 2 there. So it's really, you'd start with your smallest numbers times 5. And since we're dealing with multiplication, it's okay. We can move stuff around. That's not a big deal. So try to put your smaller numbers first. This is what I would like to see, because that's what your textbook will expect. And that's really how you're going to see it on tests and quizzes. All right, so let's break down another number. Well, let's look at number 2 at kind of the bottom of the page. Guided practice, number 2. What is the prime factorization of 24? All right, so you're going to make your factor tree. 24, I'm going to do 6 times 4. And they both get broken down. We have 2 times 3 and 2 times 2. Okay? So, I'm going to put all of my lowest numbers first. So I have 2 occurring 3 times. Whoa, what am I doing? 3 times. I was thinking 3, so I wrote 3. So we have 2 times 2 times 2 times 3. Now thinking back to what you learned yesterday, what can we do about this? How can we make it smaller so we don't have to write as much? Well, what about an exponent? Can we plug in an exponent there instead? Sure can. So 2 times 2 times 2 would be 2 to the cubed times 3. And that is actually how you see it in the textbook, because the answer is G. You're not going to see this answer. You're going to see this one. That's the correct answer. So you're breaking it down even smaller. This is where we see our exponents come into play. Got it? All right. One more page. Please turn the page. Or sorry, at the bottom. Before you turn the page, go back. Very bottom. There's something called a monomial. 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 It kind of sounds like my homie or something. All right, and a monomial is either a number, a variable, or both multiplied together. Remember, product means multiplication. So an example, like a monomial would be something like 7, or x, or 7x, or it could be really complicated. 2x, 5e cubed. Like that's all still multiplied together, and it's still considered a monomial because it is the product. Things are being multiplied together. So that would be something like a monomial. Monomial. I don't know. I think math people would get on my case for saying it wrong. Anyways, turn the page. 488, the last examples. So it says factor each monomial. So our first example is 11r cubed s. So we are breaking it down. We're breaking it down now we're going to the long drawn out thing. So 11 all by itself, I mean it's being multiplied by r, but there's nothing else happening. So we write 11. Now, how many times are we going to write r? What does our exponent tell us? Exponent says write it 4 times. 3, 4, and then we're left with s. And that is our final answer. We have broken it down to all of the factors. That's what it means for factor each monomial. All right, let's look at 3b. Last one, 12q squared r cubed. All right, break it down. We got a 12 in front, and we have a q, and we have that twice. Then we have the r 3 times. And that is our answer, factoring it. Okay? So, in a way, we're kind of doing some problems we do extra work, some problems we want to find less amount of work. So that is how you solve these problems. Again, if you have any questions, still waiting, I guess, for someone to say, Mr. T, I have a question, and it's because I'm stuck in the video. Please raise your hand. Again, that's why I'm here. And as always, I will help you and see you in real life.